Hello guys, welcome back to Techdose, and in this video we will see the median of two sorted arrays. This is from lead code number 4 and this is from our Techdose 100 sheet, so you can find the link for this in the description below. We will look at all the follow-up questions at the end of the video, so stay tuned till the end.
Are you ready to take your programming skills to the next level? Well, you are at the right place. Welcome to our Data Structures and Algorithms live interview training program, TwoPointer. Get ready to dive deep into the world of efficient coding and problem solving. In TwoPointer, you will get a solid understanding of key data structures such as array, stack, queue, heap, trees, and along with that, you will also master powerful algorithms based on maths, geometry, graph, and dynamic programming. What sets TwoPointer apart from other courses is the live interactive format. You won't just be watching the pre-recorded sessions, but you will join me along with other passionate learners in real time, where we will be covering the concepts together. Imagine having the opportunity to ask questions, engage in discussion, and collaborate with your fellow learners. It's a supportive community where we all grow together. But it doesn't stop there. We will dive into hands-on coding exercises, solving real-world problems, and you will get to work with the interview assignments that will showcase your newfound expertise. Taking TwoPointer has already been a game changer for a lot of students and working professionals. It didn't just help them to improve their coding skills, but also boosted their confidence for tackling complex problems. The live interactive sessions make all the difference. Unlock your coding potential by taking the first step forward. Contact us on WhatsApp for more details.
Let us first look at the problem statement. In this problem, given two sorted arrays nums1 and nums2, each of size m and n respectively, you need to return the median of the two sorted arrays, and the expected time complexity in this case is order of log of m plus n. Now let us look at an example for better understanding. Let's say that you have an array A in ascending order and array B in ascending order, and you are required to find the median. The simplest way to find the median is you need to convert it into a merged sorted array, where you merge these two sorted arrays into a single one, and then you will have the size of this array as m plus n as mentioned here, and simply you can find the middle element to be the median element. Now there will be two cases. For odd number of elements you will just have one middle element, as in this case you have just 4. But if it was having a total of even number of elements, then you will have two median element, m1 and m2, and you have to take the average of them to find out the median. If you follow this technique of merging these two arrays into one, then you will require some extra space for this, which is order of m plus n, and for the merging process you will require the time complexity of m plus n. After merging you can find the median in order of 1 time. Now this is the simplest possible solution for finding the median of two sorted arrays. Now if we try to understand what the median actually is, the median is nothing but the middle element, which will divide the entire array into two parts, the left pool and the right pool. You can imagine that whatever is in the left pool will always be less than equals to whatever is in the right pool. So I can say that the maximum element in the left pool will be less than equals to the minimum element of the right pool. And this is always true when you have a sorted array. Now based on this technique, we can also apply the two-pointer approach to solve the same problem of finding median of two sorted arrays. How we can do that? We know that if m is the number of elements in the first array and n is the number of elements in the second array, in this case m is 3, n is 4, then the total number of elements are 7. And hence, you know that since this is odd, you will have the fourth element as your middle element, okay? So if fourth element is the middle element, how many elements will be to the left of the median and how many will be to the right of median? Exactly 3. Because this is one element and the total elements are 7 and the median is exactly the middle element. So if you want to reach to the median from the left hand side, you need to skip 3 elements in this case. And how to do that? You can actually apply the two-pointer approach, take P1 and P2, and since this array is assumed to be in ascending order, you need to keep skipping the elements. You want to skip 3 elements, so keep skipping the elements in ascending order. So let's keep a counter equals to 0. Compare P1 with P2, whichever is smaller, just skip it. So skip P2 to the next element and increment the counter. Now compare 2 with 4 and skip P1 to the next element and increment the counter. Compare 4 with 4, Since they are equal, you can move any pointer you want. So let's move P1 to the next element and increment your counter. Now since the counter says 3, this means that you have already skipped 3 elements. And since you have skipped 3 elements and you are seeing 2 elements 6 and 4, the minimum of these two will be the median, because the larger one will be the next element of the median. I mean, it can be the next element, but it will be definitely in the right pool. So this is how you can apply the two-pointer approach to skip half of the elements from the left side to reach to the median element. And in this case, we are not using any extra space, so the space complexity is order of 1, but the time complexity will still be order of m plus n, since we are still traversing half of the array elements. So this is a better approach than the previous one, because the space complexity is improved, but the time complexity is not improved. Now we need to do better than this as asked in the problem statement. So before moving on to the optimal approach, we need to see some of the important points. So I have written down 3 points to consider. The first point is, how do you create the correct partition size? So let's say you have array A and array B of size m and n. Now by partition size, I mean that what will be the size of the left pool and what will be the size of right pool if you consider the entire array to be divided into 2 parts. Now if you have odd number of elements in total, the median will be included in the left pool. And if you have even number of elements, then the first median will be in the left pool and the second median will be in the right pool. This is our assumption for creating the partition. Now on this assumption, let's try to find out how to create the correct partition size. Now you know that if you have odd number of elements, let's say it is 9, then 5 elements will be in the left side and 4 elements on the right side. Why? Because the median is also coming on the left side. This is the same we assume in the merge sort or in binary partition, whatever. Now if you have even number of elements, let's say 8 elements, then since you have 2 medians and each one of them goes to either side, so the left partition will have size of 4 and the right partition will also have a size of 4. Okay, so this is our size division for the left and the right pool. Now in the first example, you see that we have 4 elements in the first array, 5 in the second array, so a total of 9 elements. So which element will be the median? It will be the 5th element. So what will be the size of the left pool? It will be 5 and the right pool will be of size 4. Now let's assume that we put an arbitrary partition P1 for array A in such a way that this will be in the left pool and this will be in the right pool. Let's assume that I have put a partition 1 there. By making this partition line, I mean that P1 is pointing to this 1, which is index 0. Okay. So once we have done this, then where should I put partition 2? It is like the two-pointer approach, but not exactly the same. So if you need to put the partition 2, you need to have 5 elements on the left pool, right? So currently you just have 1 element. So you can count 4 elements from here and put partition 2 at this place. Just at index 3, and you can do this in order of 1 time. Just by seeing the index, you know how many elements you need in the left pool, and automatically the rest of the elements will fall in the right pool. This is the way you create correct size of the partition. Now let us take some other scenario. Let's say that you had put partition 1 here, right? Partition 1 here. Then this will mean that you have 3 elements on the left side and 1 element on the right side. How many elements you need on the left side? You need 5. So you know that you need to put partition 2 here, so that you have 2 elements on the left side and you have the rest of the elements on the right side. This is how you create correct size of the partition. Another case can be, let's say you take partition 1 here, then you need to take partition 2 at this place. Simple. So I hope you have understood how you need to create correct size of the partition. We will see how to actually implement this later on. But let's first try to understand this visually. Let's take another case of even size array. So when both the arrays are of even size or both are of odd size, total elements will be even. So in this case, I mean, it's just the same. Let's say we have put partition 1 here. So you have 3 elements on the left side and 1 element on the right side. Since the total elements are 8, you have 2 medial elements. So 4th element and the 5th element. and you need to take average of them to find the median. So the left pool will have 4 elements, the right pool will have another 4 elements. So if you have already taken 3 elements on the left side, your partition 2 must be here, so that you have 1 element on the left, so that the total number of elements on the left side are 4 and the total number of elements on the right side is 4. Okay, this is how given partition 1, I'm saying given partition 1, how to know where to place partition 2. So if you know this, if you understand this, then you know about creating correct partition size. This is the first point. The second point is, you know, there are a lot of ways to create partition, but there will be exactly one way which is correct and the rest of ways will be wrong. Now let's say that in the first example you have m as the size, which is 4, and n is equals to 5. Again, you know that the fifth element is the median element and the left pool size must be 5 and the right pool size must be 4. So if I put partition 1 here, then I need to put partition 2 at this place. Okay, it is the same thing which I explained earlier. But is this correct? Now after putting the partition, you know that 5 elements are on the left side, 1, 2, 4, 6, 8, and 4 elements are on the right side, 5, 7, 8, 9. Now for checking the correctness, the maximum element in the left pool must be less than equals to the smallest element on the right side. Okay, this is the same thing which I had explained here, I think on the first slide, that the maximum in the left pool must be less than equals to the minimum on the right side. So it is the same concept which I am applying here. Now since the first array is sorted, you know that 1 will always be less than equals to 5 and 8 will always be less than equals to 9. So you need not check the elements order in the same array because they are already sorted. So what you need to do is, you need to cross check. You need to check this 1 with 9 and this 8 with 5. You need to cross check the boundary elements. Why the boundary elements and not any other element? Because if you look at it, will 6 be a best candidate to be compared to 5 or 8? I think 8, because 8 is the maximum element in this array, right? On the left side. So you need to take the maximum of the left and the minimum of the right on both the partitions. So 1 will be compared against 9. Since 1 is smaller, it's fine. 8 will be compared with 5. And if 8 was smaller, then it was fine, but it is not. And again, I am explaining that 8 is the best candidate, because even though I would say that this 4 is compared with 5 and 4 is smaller, it doesn't guarantee that everything to the right of 4 which is larger than 4 is also less than 5, right? It is not guaranteed. Hence, we need to take the best candidate. So since 8 is larger than 5, therefore this is not a correct partition, because there is some element on the left side, on the left pool, which is larger than the element on the right side. So this is not a correct partition. Okay, so to simplify this comparison, I will name this, the rightmost element in the first array on the left side as x, and the leftmost element in the first array on the right partition as y, and this as p and this as q. So you need to compare this x against q and this p against y. So you need to simply do this comparison, that x must be less than equals to q and p must be less than equals to y. And hence, if this is correct, then the partition which you have created is the correct partition, and then you can easily find out the median. In the odd case, you will see that the maximum of this x and p will be the median. Why? Because you had one extra element on the left side, hence the median was included on the left side. I already assumed this here, right? Median was on the left side. The largest element on the left side was the median in odd case. In even case, both the partitions will have 1 median. So if you look at the even case here, the correct partition for this will be P1, P2 at this place, because 5 is less than equals to 6 and 4 is less than equals to 7. Now since this is an even case, there will be 2 median, one on the left pool, another one on the right pool. So the largest from the left pool is 5. The smallest on the right pool is 6. So these two are the median. So you take the average of them to find the median. So this was your x, this was your y, this was your p, and this was your q. So maximum of x comma p plus minimum of y comma q by 2. Okay. So this is the second point. I hope you understood this. Let's look at the third point. It is the boundary case. Now in this scenario, if you want to create a correct partition, let's say that you have put a P1 here. In this case, the size of M is 3 and N is 6. So a total of 9 elements. Hence, the fifth element will be the median element. If you put a partition 1 here, you will see that partition 2 will come at this point. Now, this is your X, this is your Y, this is your P, and this is your Q. You can easily compare X with Q, but how will you compare P with Y? There is no element here, right? And therefore, you will have to insert something here, some dummy value. So I will insert integer maximum, because integer maximum is considered to be infinity, and this case must always pass that 4 will be less than equals to this boundary element. Otherwise this partition 1 will be moving further to the right, which is not allowed. So you need to insert an integer maximum here. In another case, I can also create another scenario where I say that partition 1 is here, right? Partition 1 is here because I can make this 100, 200 and 300 in such a way that partition 1 is in the first point and then partition 2 is here. Now you have exactly 5 elements on the left pool and 4 elements on the right pool. So this is your X, this is your Y, this is your P and Q, but then X doesn't have any element. Hence, I will be inserting minus infinity or integer minimum, so that the comparison is easier. That if you compare this Q with the out of bound element on the left side, then this element must always be greater than equals to the left hand side out of bounds elements. Okay. Therefore, I will say that before solving the problem or even while solving the problem, you should assume that the out of bound element on the left side is integer minimum and on the right side is infinity. So this will increase the array size by 2 for both of them, but it will handle all the boundary cases. So I hope you understood all the 3 points. If you did, then let us look at the optimal approach. Now in this case, the optimal approach says that, you have m elements in the first array, n elements in the second array, and the idea is to just create the left and the right pool. You already know how to create the partition. So let's create the partition from left to right one by one. Let's try that out. So if I create a partition 1 here, you know that m plus n size is equals to 9 in this case. Therefore, left pool will have 5 elements and the right pool will have 4 elements. So if partition 1 only one element is on the left side, then you know that partition 2 must be at this place in order of 1 time. And now you have to check for the correctness of the partition. So compare this 0 with 9, it is fine, it is in ascending order. Compare this 7 with 2, it is not in ascending order, right? So this is not a correct partition. So again, now move on to the next possibility. So I'll just remove this and move on to this 2. So if I create a partition 1 here, your partition 2 will move at this point. Compare this 2 with 7, it's ascending order. 5 with 3, it's not in ascending order. So again move P1 to the right. And this will be your P2. Compare 4 with 8, it is in ascending order. 3 with 5, it is in ascending order. Yes. Then this is the correct partition. And since this is having total of odd number of elements, therefore the maximum of this 3 and 4 will be the answer, which is 4 in this case. Okay. So what is the time complexity? The time complexity is you have to linearly traverse through each of the element in array A, and you need to find out the correct position of the partition 2 in array B, which is done in order of 1 time. So the time complexity will be order of m. If you assign the smallest array to array A, then the time complexity will be order of minimum of A comma B. I will say m comma n, which is the size of the arrays, right? If you assign the minimum array to A. But this is not the optimal approach. The optimal approach asks you about the logarithmic order solution. So this is again not optimal. Now what we can do is, instead of finding out the correct partition from left to right, since this is a sorted array, we can apply binary search on this. Now binary search cannot always be applied at every places. The most important condition in order to apply a binary search algorithm is, once you have put a partition, let's say the middle element, and if it doesn't work for you, then you should exactly know which way to go, left or right. And you must make this decision with 100% guarantee that if something happens, I move to left. If that doesn't happen, I move to right. And that should always be correct. Okay, if you can make such kind of decision, then you can apply binary search. In this case, let's try to see if we can make such kind of decision. Now let's take the second array, and it is just the same as the first array. So if I try to apply binary search on it, I will apply binary search on the first array. So I'll put partition 1 here. Putting partition 1 here is P1 is pointing to index 1. Now since this has 2 elements, I know where to put partition 2. Now simply compare 4 with 7, it is ascending order, and 5 with 6, it is in ascending order. Now this was a very simple example which got solved in just a single attempt. So I'll take another example. Let's say that you have an array A and an array B. Now in this case, you have m plus n elements equals to 10, and this is even. So you know that you need to have 5 elements on the left side and 5 elements on the right side. If you apply binary search on this, your low value will be 0, your high value will be 3, hence your mid value will be this one, which is 1. So this is your partition 1. Now where should be the partition 2? You know that there are 2 elements on the left side, you need to have 5. So it will be the third element where you put, that is index 2. So this is your partition 2. So you have created correct size partition. Now you need to check for correctness, which was 0.2. 0.3 is already taken care because I am assuming minimum on the left and maximum on the right. So check this 2 with 8, it is in ascending order, fine. 6 with 3, it is not in ascending order. So it is not correct. Now if I move this partition 2 on the right side, you think about it carefully. If you move this partition 2 on the right side, partition 1 will automatically move on the left side. Okay. So if you move partition 2 in the right side, it is not the correct order if you think about it, because the values will keep increasing. The maximum value in the left partition for the second array will keep increasing if P2 moves to right. But what we actually want is we want to decrease this value, so that once you compare this, if this is x, y and this is p, q, we want to decrease the value of p because p is larger in this case as compared to y, but we need p less than equals to y. Okay. So if you need that to happen, then this P2 must move on the left side. Therefore, you can assume that P1 must move to the right side. This is how you can decide on which way your binary search will move. So you know that you need to move on the right side. So what must happen is your low will be mid plus 1. So this will be your low. 3 is your high. So your midpoint will be 3 in this case. So this is now your new partition 1. And if that is your new partition 1, that is, it has 3 elements on the left side, this will be your partition 2. Now you compare this 4 with 4 and 3 with 6. Both are correct. Both are in non-decreasing order. So this is a correct partition. And since you have even number of elements, you will have 2 median elements. The maximum of this one, like if this is x, y and this is p, q, the maximum of x and p, which is 4, plus the minimum of this 4 and 6, which is 4 by 2, and hence your median will be equals to 4. Now in this case, you had applied binary search on the first array, so that will be log of m, and you applied order of 1 time in finding out where P2 will be, because it is just based on the count and the index value. So this is order of 1. Therefore the total time complexity will seem to be order of log m. But then if the minimum size array is given to A, then that will be order of log of minimum of m comma n. Okay, if I assume that the minimum size array is going to A, so that will be the time complexity, and the space complexity will be order of 1. Before looking at the code, let's look at the follow-up questions. The first follow-up question can be find median in row-wise sorted matrix, and the another follow-up question can be finding median in a column-wise sorted matrix. We will cover this in separate videos, hence I will not explain this here. Now let us look at the code. The code here is very self-explanatory as explained in the video. This is the nums1 array, which is A, and the nums2 array, which is B, and this is the size, which is m, and this is the size, which is n. In this code, I have interchangeably taken this m with n and n with m, but I think it will not hurt any explanation or any understanding. So I will assign the smallest array to array A. So this is for that case. And after that, this is the binary search condition. This is the entire binary search code. Inside this, I will first decide on where should I put the partition. So this is for putting the partition. Okay, so you can follow all the points to find out what is the size of partition. Once you have found out the size of partition, this is checking the correctness of partition. Okay, so the first one is for even case, the second one is for odd case. So this if statement checks if the partition division is correct. That means the size will always be correct because we will divide it based on the correctness of size. But the second criteria, the second point is if the maximum, I mean if the partition was correct itself, right? I mean if you compare the x and y with p and q, the condition was x must be less than equals to q and p must be less than equals to y. This was the second point. So this is checked here. If this is also true, if first and second point is true, we have already taken care of the boundary element, which was the third point. So everything falls in place. So now we need to check if it is even, then you will have the average of two middle elements, and if it is odd, you will just have a single middle element, right? But if this is not true, if the second point, that is the correctness check, is not true, then we will do binary search either on the left side or on the right side, depending on which way we need to move partition to. Okay, so if you just dry run this by seeing the explanation, I think you must be able to understand this, and this is a very important question for your interview. So please practice this and do code it. Follow me on Instagram and LinkedIn for more interview tips. Subscribe to our channel for more such videos. See you guys in the next video. Thank you.